January 2010 AS2, and we'll be looking at question 5. Okay, so the basis of this question is determining the formula of an unknown hydrocarbon. And so the first thing we need to do is write the general equation for the combustion of a hydrocarbon. So a hydrocarbon is something that contains hydrogen and carbon only. Because we don't know how many carbons or how many hydrogens, we can represent it as CXHY. So X represents the number of carbons we have and Y represents the number of hydrogens we have. So combustion is the reaction with oxygen to produce carbon dioxide and water only. Now, even though this is a general equation and we don't know the number of carbons or hydrogens that we have, we still need to balance it in a general way. So if you think about how you would balance a combustion equation, the first thing you do is balance the carbons with carbon dioxide. So I can see that I've got X carbons, so that means I need X carbon dioxide, so that I have the same number of carbons on both sides of the equation. What do you do next? You balance the number of hydrogens with water. And you can see I have Y hydrogens. But on the right hand side you need to be careful because you've got H2. So any number you put in front of the water is going to multiply the number of hydrogens by 2. And so in that case we have Y over 2 hydrogens. Because we have Y hydrogens on the left, but we have Y over 2 H2s. Okay, the next thing we do is we balance the number of oxygens. So first of all, let's count up how many O2s we have on the right hand side. And so on the right hand side we have X times O2, so we're going to have X number of O2. But we also have Y over 2 O, but we're interested in the number of O2s. And so I only have Y over 4 O2. Because that little 2, if I times that by 1 over 4, I'm going to get 1 over 2. So on the left hand side then, I can put X plus Y over 4 O2. Okay, so that is your equation generally balanced for the combustion of a hydrocarbon. Now, looking at the question, you need to be careful about how you read these questions. So I've been told that 10 centimetres cubed of the hydrocarbon was completely combusted in 70 centimetres cubed of oxygen. However, that was an excess. What that means is that more was added than was needed to react. So it's not that 70 centimetres cubed of oxygen reacted, it's that that is how much I added. And then the final gaseous mixture, it contains 30 centimetres cubed of carbon dioxide and 20 centimetres cubed of unreacted oxygen. So let's write down that information underneath the relevant parts of the equation. So first of all, we know that 10 centimetres cubed of my hydrocarbon reacted. The next thing we know is that 30 centimetres cubed of carbon dioxide is produced. Now, how do we work out the volume of oxygen that reacted? Because we're not interested in the volume of oxygen that was added, we're interested in the volume of oxygen that actually reacted with the hydrocarbon. So we can work that out by doing volume of oxygen used is going to be the volume we added take away the volume that was left over at the end. And that's the unreacted oxygen. We can see from the question that we had 20 centimetres cubed of unreacted oxygen. So it's going to be 70 centimetres cubed minus 20 centimetres cubed, which gives us 50 centimetres cubed. Okay, so I'm going to rub out that to give us some room. So we know that 50 centimetres cubed of oxygen reacted. So again, we can write that underneath the equation. Okay, now if you remember back to when we talked about molar gas volumes, we learnt that the volume of any gas, 1 mole of any gas is 24 decimeters cubed at room temperature and pressure. So if you remember the equation, volume equals N times 24. That means 1 mole of any gas occupies the same volume at a given temperature and pressure. And so what we can do from that, what's helpful from that, is that we can take these volumes to equal the mole ratio. So you can work out the number of moles of each, but you don't need to do so. So that means we can take the mole ratio, or the stoichiometric ratio, in other words, to be 10 to 50 to 30. And to simplify that down, we can divide each of them by 10 to give us 1 to 5 to 3. So the balancing numbers of our hydrocarbon to oxygen to carbon dioxide are 1 to 5 to 3. Okay, so from that I can work out what my balancing numbers are, what X and Y are. So if we look at this, 3 is going to equal the balancing number of carbon dioxide. So that means that X equals 3. So from that I can tell that I have 3 carbons. So the start of my formula is going to be C3 and then HY. But I don't know what Y is yet, because it could be an alkane, could be an alkene. And so I can get that from my mole ratio of oxygen. So we can see here, we'll do this in a different colour, that 5 will be the balancing number of oxygen. So that means that X plus Y over 4 is equal to 5. Now I know what X is. We worked out that X was equal to 3. So 3 plus Y over 4 is equal to 5. Now, rearranging that equation, I'll continue it up here. We can bring 3 to the other side of the equation, and that means Y over 4 is 5 minus 3, because we're bringing 3 to the other side of the equation, and so it becomes a minus. So Y over 4 is 2, and then bring the 4 up to the other side. And so it's dividing on the left hand side, and so it's multiplying on the right side. So Y is going to be 2 times 4, which is 8. And so if Y is 8, and my formula of my hydrocarbon is CXHY, then I just substitute them into the formula for my hydrocarbon, and I get C 3, because X is 3, and H 8, because Y we worked out as 8. So it's really just using gas volumes and remembering that 1 mole of any gas occupies the same volume at a given temperature and pressure, and using these to work out your balancing numbers. Now I would recommend that you learn this top equation, this general equation for the combustion of a hydrocarbon, as that will help you. It will help you save time in an exam if that comes up. So remember that it's CXHY plus X plus Y over 4 O2 goes to give you X CO2 plus Y over 2 H2O. And also, if that sort of thing makes sense to you, that will help you balance an equation for combustion if you remember those general numbers.